right, electromagnetic radiation objective 2 practice. Remember, pause the video after I read the questions so you can think of your answer. Unpause to see how you did. Here we go. That means more than one of these answers are correct. Which of these phenomena can be explained by the wave nature, not particle? Waves, not particles. So go ahead and press pause while you think of it. All right, so there's 4 that are going to be waves. You might even want to write this down and pause it after I go over it. 3 of them all end in TION. So refraction, diffraction, reflection, all TION, and one you might see later, and it's sloppy, but it's called interference. So all of those are examples of wave nature, light acting like a wave. Which of these are explained by the particle nature of light? So from the last question, we know it's not one that ends in TION or interference. So press pause while you think. All right, so there's going to be only 2 we need to remember for particle. One of them, like the word particle itself, starts with a P, and that's photoelectric. And the other is going to be that light can travel in a vacuum, like outer space. So again, you might want to write that down to use on your quiz. Sorry it's so sloppy. But again, particle nature, 2 pieces of evidence. One starts with a P, like the word particle, photoelectric, and the other is it can travel in a vacuum, which you will see later. Wave particle duality. What is that talking about? Press pause while you think of the answer. All right, hopefully you know that the word dual means 2. And the 2 things we're talking about are the 2 words before it, particle and wave. So if we look for an answer that talks about acting like waves and particles, we're good. And sure enough, red says EM waves act like waves and particles. 2 things dual means. Which of the following is evidence that supports the particle? Ooh, we talked about this earlier. Press pause. All right, if you remember, we said there were 2. The one that started with P, which is not on here, and the other we said it can travel through a vacuum like outer space. So there it is. Remember, wave evidence ends in TION or is interference. Particle starts with a P, so the evidence starts with a P, photoelectric, or can travel in a vacuum. Which pair of the following experiments supports the theory of wave-particle duality? It's probably the toughest question of this practice. Go ahead and press pause while you think of it. All right, remember, particle is going to be the one with a P, so that means it has to be this answer or green because they both have photoelectric. The other answer, we spent probably half of a whole video talking about the double slit experiment. So hopefully you remember that. There's no trick for that half, but you should know the P for photoelectric. Then hopefully you remember the video and its double slit experiment. Which of the following supports the wave model? So go ahead and press pause. If you remember from earlier, we said the wave model, all the evidence ends in TION or is interference. And this one is the interference answer. Which of the following is not a wave property? So if it's not a wave, it's a particle. So we could think of it in 2 ways. What's particle evidence or what is not wave? And we said waves all end in TION. TiON, TiON, TiON. So none of those can be that because it says not a wave, and we know those are waves. And that leaves us with light does not require a medium. Remember, that's really the same thing as saying it can travel in a vacuum like outer space, but they just mixed it up. Which of the following is evidence that light can be described as a particle? Press pause. Remember, P for particle, P for photoelectric. The other could be travels in a vacuum, but that's not here, so we're good with green. All right, you should be good for your quiz now. Good luck. Make sure you look over the answers from here and you're